Dear students, you are welcome to another segment of scheduling algorithm, that is shortest remaining time SRT under the preemptive scheduling, where you will find a different example. The example is being shown over here, that a given table is being displayed. Under the table you have to draw a Gantt chart as well as compute a time arrival turnaround time as well as waiting time. I have discussed about the preemptive and the non-preemptive earlier. Preemptive means a process in which a CPU can stop in the middle. That means CPU can stop the process in the middle and divert to another process. Non-preemptive means when a process is running, it can do only other task, or it can only release the CPU after completing that given task. So CPU cannot be released from the process under the non-preemptive situations, but in the preemptive situations it can be released. So this is another version of SJF. We can term it as a SJF, shortest job first, or this particular also can be termed as shortest remaining time first. So this algorithm is also an interesting based on the new problem that has been displayed. So let us see how this particular problem has to be analyzed. You all know that P1 is the process which takes 8 burst times. P2 is the process which takes 4 burst times. P3 is the process which takes 9 process times. P4 is the process which takes 5 unit process time. So since it is under preemptive, we cannot run the whole process with it, so we have to look after this process. Same is the same, we cannot take the whole process of a P3, we have to look after the subsequent process also. Now here you have to see that how we can going to put the Gantt chart based on the table. So assume that as per the common condition is that whenever the process 0 arrives, a process P1 arrives at a 0 arrival time, so we will put the first process P1 here, and based on the P1 process we are denoting 0 as the arrival times, and instead of running for 8 units of times, we will try to take a process not with the lowest burst times. Rather we should see that the arrival time is important to put the initial Gantt chart till the ready queue condition is satisfied. I repeat again, we have to put the Gantt chart in such a way that until the ready queue condition is not reached, we have to go with the selections of the burst times such that the whole process comes in the queue. That means the process P4, P3, P2, the order at which it has to come, it will be accordingly designated. So when the process P1 comes for a 1 unit of time, so it will be 1 here. So what you are observing, when at the arrival after the 1 unit of time, it is equal to the arrival time of the process P2. So we can put a process P2 here. So here, since the P1 has process, here the priority has no value, so I am putting the remaining time as, since we have added plus here, so -1 here, so it becomes 7. Now P2 has arrived, it has a burst time of 4. So instead of allowing it to run for a 4 unit of time, what we do is that we go with the burst time of only 1. So it becomes 3 here, and here we add plus 1, so it becomes 2 here. Now next comes the process P3. So at 2 what happened? Process P3 has arrived. Now here what we do, the process P3 is being made to arrive. When the process P3 arrives, what we are going to do is we are going to add another one more unit of time and computing, and we are making the process P3 execute by 3 units of time. So from here also we are computing, and we are bringing -1 here and making it 8. Now at 3 you see the whole 4 process has arrived. So this particular segment is called as ready queue, RQ, or this is a RQ. Now after RQ, what is the next stage? As I told you, after the RQ, everything go as a non-preemptive situations. So in the non-preemptive situations, what happens? We go with the process and we'll try to see that which is having a smallest burst time, because under the shortest remaining conditions, we look for the process is based on shortest burst. This is you have to remember. Now here we will put after P3 what comes to the mind is that one we normally think about 5, but you see the latest condition is 7, 3, 8 and 5. Among this, P2 is the shortest. So P2 will process for how much times? It will process for is it going to process for a total 3? It is going to process for a remaining times based on the remaining time 3. So we will be putting +3 here. So 3 plus 3, it comes as 6. 3 plus 3, 6. And based on the next process is what? After 3, the next after the process P2, we will be going with the process as, if you see this process, the next process is coming as 3, 5, P4. So P4 means what? It is going to compute same +5. So +5 means 11. After P4, what is going to compute? The going to compute is P11, P1. You just see 7 is there. So it is 7. So it is going to add 7 means it is going to become 18. Now after P1, which is the last process, the last process is P3. So P3 is how much? It is going to becomes +8, because not 9 plus 8. So here it comes as 8 plus 8 is it coming as 26. So here this also becomes the +5 in the previous. So it has been processed 0. From here it becomes 0. From here it becomes 0. Here it also it becomes 0. Now let us see the completion times. If you see from here CT, which process completes at the last? P3. So P3 completes at the time interval of 26. Now what is the next process which is going to complete after just before P3 is P1. P1 is 18, and before that P4 is 11. After before this one is 6. So this is the entire process that you have seen, that the whole process is being designated in the order of this one. Now one thing you have to keep it in your mind, that since it is a preemptive situations, you have to be very careful about the burst times. We cannot run with switching over, and also if the burst time here, if you reduce it, your eye should be over on the remaining time. Now let's compute the TAT. TAT is 18 minus TAT is nothing but completion time minus arrival. 18 minus 0 is 18. 6 minus 1, 5. 26 minus 2, 24. And 11 minus 3, it is coming 8. And waiting time is nothing but time turnaround time minus burst times. The 18 minus 8 is 10. 5 minus 4, 1. 24 minus 9 is coming as 15, and 8 minus 5 is 3. So the next part is what? Average waiting time is nothing but 10 plus 1 plus 15 plus 3 divided by how many process? We are having 4 process. So to compute the 4 process under this particular case is 10 plus 5. This is coming as 26. 15, 16, 26, 26 plus 3 is 29. 29 divided by 4 is coming around 6 point, it comes around 6.8, and average turnaround time is nothing but 18 plus 5 plus 24 plus 8 divided by 4. So this is coming around 18 plus 5, 23, and plus 24 is coming as 47, plus 8 is coming as around 55, divided by 4, it is coming as 11.2, around 11.2. So this is the two important components normally asked: average waiting time and average turnaround time in all the questions. So this completes the SRT algorithms, and I believe that you have understood based on the given ideas. Thank you.